Okay, my presentation is on the electric vehicle. We're going to be going over the introduction, its history, what's been done, impacts and implications, and with all of this being said, weighing the pros and cons, it'll be your decision whether or not you would like to support it in the future. To start, an electric vehicle operates on the following components: the electrical traction motor, the power electronics controller, the DC-DC converter, the thermal systems for cooling, a traction battery, a charging port, transmission, an onboard charger, and main battery. The manufacturing of motor vehicles, whether gas-powered or electric, creates emissions that can affect our environment. You may have heard rumor that EVs are worse than gas-powered vehicles in emissions, but this is only in the manufacturing of the vehicle itself. EVs can produce up to 80% more emissions compared to gas vehicles in production. However, MIT conducted research over time and found that on average, gasoline cars emit 350 grams of carbon, whereas hybrids release, whereas hybrids release 350 grams, Okay, so gasoline cars can emit 350 grams of CO2, whereas hybrids scored at around 260, and fully electric vehicles scored in 200 grams overall through the course of their life. Another large contributing factor to EV emissions is how owners are powering their vehicles. The mining of lithium for EVs also contributes to emissions from the machines being used in harvesting. It was found that this is 40% of emissions released throughout the manufacturing of EVs batteries. And the extracting lithium can also be quite hazardous to the workers, as a majority of mining is done in underdeveloped areas, which provides poor protection equipment for the workers. Once lithium-ion batteries are produced, however, emissions are far less with EVs compared to gas-powered vehicles over their respective lifetimes. Electric vehicles were first introduced over 100 years ago in the 1800s. Blacksmiths, chemists, and scientists alike tried to come up with their EV inventions. Over the years, EVs started appearing all over the world. New York had at one point a fleet of more than 60 powered electric taxis. In 1898, Porsche's founder, Ferdinand Porsche, developed their first EV called the P1, and sometime later created the world's first hybrid EV, a vehicle that is powered by both gas and electricity. Friends Thomas Edison and Henry Ford worked together to find more efficient and low-cost EV, but later in 1908, Ford's Model T would put a damper on EV sales. Back then, a Model T only cost $650, whereas an EV Roadster had sold for $1,750. A hand crank made it difficult for a lot of people back then to start their gas-operated vehicles, but in 1912, Charles Kettering introduced the electric starter, eliminating this need, giving further rise to the gas-powered vehicle. Among other gas-powered developments, the discovery of crude oil in Texas allowed gas to become cheap and readily accessible. Electric vehicles had all but vanished by 1935. And this is a picture of the salt flats farmers used to produce the salt flats and then harvest the lithium after time has elapsed, and lithium has grown on the salt. By 1973, oil prices and gasoline shortages peaked with the Arab oil embargo. Americans sought to find an alternative method to remove U.S. dependence on fuel. This led Congress to pass the Electric and Hybrid Vehicle Research, Development, and Demonstration Act of 1976, supporting the Department of Energy's exploration into electronic vehicles. General Motors, Jeep, and even NASA attempted to bolster EVs during this time. General Motors created a prototype for an electric urban car. The USPS, United States Postal Service, was provided electric delivery Jeeps in a test program, and NASA became the first to use EV manned rovers on the moon. Nevertheless, EVs still lacked the same efficiency as a standard gas-powered vehicle, as they were only able to travel at a top speed of 45 miles per hour with a typical range of 40 miles before having to be recharged. By the 1990s, pollution worldwide had governments renewing the research and interest into EVs. General Motors manufactured but never made commercially available the EV1, which they designed and developed from the ground up until the end of its production in 2001. The EV1 was the first of its kind with the availability to drive up to 50 miles an hour in just 7 seconds and had the range of up to 80 miles. The EV1, however, was not as efficient as gas-powered vehicles of its time and was never able to go public because of costs to make it were not viable. And this is a picture of the EV1 and the Moon Rover. With EVs now gaining traction, the government as well as automakers and other private businesses together established more than 20,000 charging stations across the US. And over the past 4 years, the DOE's research team also introduced lithium-ion battery, which has cut EV battery costs by 50%. Hard to believe considering they're still very expensive. More currently, President Obama launched the EV Everywhere Grand Challenge, a Department of Energy initiative that brings together America's best and brightest scientists and engineers and businessmen to make plug-in EVs more affordable by 2022. Research is also being worked on locally at the Argonne National Lab. The true rise to mass-produced EV was a hybrid started in 1997 in the Aichi Prefecture of Japan with Toyota's Prius. Since then, in 2006, Tesla Motors produced an EV capable of traveling over 200 miles on a single charge. The Department of Energy granted Tesla with a $465 million loan to establish a manufacturing facility in California. Tesla was so successful that they managed to pay back the loan early in under 9 years. Since Tesla's success, other companies have been inspired, with Chevy creating their version of the Volt and Nissan releasing its version, the Leaf. Electric vehicles can be more efficient in being sustainable over the long term if used correctly. You would think that owning an electric vehicle and charging would be a great contribution to sustainability. However, it is only dependent on where you are getting the energy from. For example, charging your EV with electricity sourced from coal or gas-operated stations will increase emissions, whereas stations run from water-generated mills or solar energy has no output of emission. For most people, half of the decision in buying an EV is based on the fact that it has fewer overall emissions. It is therefore lack of information that has EV owners continuing to contribute to these emissions, since they don't know how they're getting how their energy is sourced. During the 2021 power shortages in California, government officials urged people to stop charging their vehicles to save power for the grid, and if owners had been more aware of that, if owners had been more aware of where the power had been coming from, and that it was a gas-operated power station, they may have set up solar panels on their house to mitigate that. The average person travels a little less than 100 miles a day, and most EVs can travel 200 miles on a single charge, with more improvements expected to come over the years. By using kinetic energy, EVs can store energy output from the process and applying the brakes. To charge their batteries, EV owners can use a standard 120-volt outlet enough to power a kitchen toaster. For more efficient charging, a 240-volt outlet can be used. The batteries of EVs can also be recycled, which drastically reduces emission output. Some EVs operate on a dual gas and electric powered system, and when the battery runs low, a reserve tank kicks in to power the engine. Unfortunately, however, weather can have a drastic impact on a battery's performance, with a 40% power reduction due to extreme cold or heat temperatures. Despite having less maintenance, when the time does come for repairs, you can expect a hefty bill with EVs when it comes to replace the battery. The average cost of an EV replacement battery is about $6,000, whereas a newer EV model could cost you upwards of $30,000 with labor fees. MIT's research, though, has shown that if the world continues EV research and development, we could see EVs releasing as little as 50 grams of emission upon production, drastically reducing costs. This would require most of us to be EV owners, as well as for cleaner energy to be used in the mining of lithium, as well as production. And last consideration, but not least, is the threat that lithium batteries pose to our first responders. The high voltage lithium batteries can have uncontrolled releases in temperature upon pressure and impact. This could cause a reignition fire and or electric shock to first responders, something researchers have been trying to mitigate. And this is pictures of hydroelectric dam, windmills, and solar panels, all sustainable ways of gathering energy. All in all, pros versus cons, it is up for you to decide whether or not you will make the EV switch when the time comes. The Department of Energy has documented research that has been released that shows the United States reserve to reduction ratio numbers, or at the present rate of use in production, we will exhaust the current reserves of oil in just 53 years, increasing U.S. dependency on foreign oil. And with that, I leave it for you to decide whether or not, again, when the time comes, to purchase an EV or stick to gas. Thank you.